Hey guys, welcome back. Today we're starting off with commutative property, associative property, distributive property, identity property, and identity property of addition and of multiplication. Alright, pretty easy. As you remember, probably, commutative property is just the order of which things, of addition and multiplication, and they'll be the same. So 1 plus 2 is the same thing as 2 plus 1. For associative property, it's the groups. So 2 plus 1 plus 3 is the same thing as 2 plus 1 plus 3. Group like this. This also works for multiplication. But remember, for commutative property and associative property, it does not work for subtraction or division, only addition or multiplication. And for distributive property, as you also remember, I hope, it's just distributing like that. So that is the same thing as 3 times 5 plus 3 times 1. And 3 times 5 is 15, and 3 times 1 is 3, and if you add them, it's 18. And let's see here, 5 plus, up here, 5 plus 1 is 6, and 6 times 3 is also 18. So that's how you know it's the same. For identity property, that's also just really simple. Actually, yeah, that's right. 5 plus 0 equals 5, and 5 times 1 is, that's a 1, is still equal to 5. So if we look at number 1 here, this would be an example of distributive property, because this 14 is being distributed into these. Alright, next page. Evaluate each expression for A equals 63, B equals 150, and C equals 7. This is also pretty easy, because you're just using these values and plugging them in and using them for these equations on this page. So for example, in number 1, A plus 205. So A equals 63 up here. So A plus 205, we're just plugging in. So 63 plus 205. And that equals 268. Pretty simple. So you're just gonna do that for these 10 problems here. Alright, for the area, we're just trying to find the area of these shapes right here. So, area, remember, for example, 3 times 4, you just multiply, and the area is 12. You just multiply the side lengths. Pretty simple. So how would you do it for a weird shape like this? So what you would do is just draw an imaginary line here, and you get 2 rectangles. So then we can solve for this first rectangle here on top. 3 times 9 equals 27. So the area here is 27. Alright. Okay. So how would we solve this? We have 4 centimeters right here, but we don't know what the side length is here. 8 centimeters is just for this whole thing. But what we do know is that this is 3 centimeters. So that means that this would be 3 centimeters as well. So if this is 3 centimeters, then this would be 5 centimeters, because 3 plus 5 adds up to 8. 3, and the whole thing is 8, so that means this would be 5. So 5 times 4 equals 20. Oops, I keep doing that. So this would be 27, and this is 5, since this is 3, and the whole thing is 8. So 5 times 4 equals 20. And then we just add these two numbers, and we get 47. And don't forget the units. Alright. So after you're done with this page, we can go to the next page. Let's try number 2. So we're given all the side lengths except for these two. We have to find them out. We have to figure them out. So this is 15 and this is 20, which means that this would be 5. Since this is also 5, if this is 5, then this is also 5. And 15 plus 5 adds up to 20. And that's correct. Alright, now for this, how would we solve this? Well, it's the same thing. This is 6, so this is 6 as well. And then this is 10, so add them up. And this is 16. So this would be 5, and this is 16. And then now we have all the side lengths, so now we just add them all up. So let me see. 20 plus 26, 26, 15, 20, 25, 51. Then 72 would be our answer if we add all of these up. Alright, so I guess that's it. After you're done, here's the answers if you want them. And see you next week. Bye.